Hello, everyone, and welcome to our podcast series on Infrastructure Repair Live. Today, we are going to be talking to you about the topic that we have seen a lot of recent applications on, about repair of timber piles with epoxy grout injection. So I thought I'll go ahead and give you a couple of a few slides on some of the background and the way you would be use it as a design. Then I have a couple of my associates here that we are actually going to show you how these products are mixed, and we have a pile behind me. You can see that we are going to be using that to fill it with this epoxy. So basically we have two kinds of epoxies that can be used for filling the annular space. One of them, one of our products is called the 320 LV for low viscosity resin. This is a neat resin that has very low viscosity, and it can fill all the voids and cracks of a timber pile if you're filling it. And usually for these, keep in mind that neat resins, if you have them in large volume, when they cure, they shrink and crack. So it's really best that you blend them. If you have larger volumes, you want to blend them with some aggregate or fine sand to make sure that you avoid that cracking. And that's really what becomes that epoxy grout, which is the second type of fill material that we use. Typically with epoxy grouts, we go with an annular space of about 3/4 inch or higher, just based on whatever seems reasonable for the project. So as far as testing of these systems and repair of these, we've got several of these done many years ago. Nebraska Department of Roads did a study. You can find all of these on our website, the reports. But it's been several studies that we've done. They show that you can fully restore the strength of a pile way beyond its original capacity with using this technique of filling the annular space with an epoxy or epoxy grout. So for those engineer friends who are here today, if as far as the strengthening of these goes, keep in mind that your typical, if we have, I'm going to divide it into two separate subjects, compression or compressive axial capacity strengthening and flexural or bending capacity. So keep in mind that when it comes to compressive strength, typical wood species, they have a compressive strength of like 2,500 or 3,000 psi at best. And then when you have these cracks or voids in between them, and you fill it with like any of our epoxies, whether it is the low viscosity or the epoxy grout, these epoxy grouts or epoxy low viscosity resins, they have a compressive strength of more than 10, 11,000 psi. So any kind of crack or void in the timber that you fill with that epoxy grout, you clearly add a lot of strength to that. And then when it comes to flexure, by bonding, we get actually, when you pour that resin in the annular space, you're bonding the PileMedic jacket to the host pile, and then they both, in combination, they resist the loads. And those values, they come from our product data sheet. So if you look at like one of our laminates, which is this PLG 1413, this is the product data sheet. When you look at the data, keep in mind that as in the picture of a roll of PileMedic shows, when we talk about we have listed in this product data sheet both the longitudinal and transverse direction. So the longitudinal direction refers to the longitudinal direction of the roll. And as you see, when you wrap the roll around the pile, it's really the longitudinal direction of it becomes in the hoop direction of your pile. And what we list in the PDS as the transverse strength, that is the one that aligns itself with the vertical axis of the pile. And so that's the one that contributes to the flexural capacity of the pile. And so I have on the next slide, I'm kind of zooming in on a couple of these tables on our product data sheet. And if you look here, you see that, for example, we listed that it is in the transverse direction, a layer of this PileMedic has a breaking force of 910 pounds per inch. And because we typically wrap these in 2 layers, so when you add them together, the 2 layers give you around 1,800 or 1,820 pounds per inch in the vertical direction. So when you look, for example, as this diagram on the right that I show you a pile that is being wrapped, all of those arrows that you see pointing up, those are the strength of the PileMedic laminate in the vertical direction that you can now utilize that in calculating the moment capacity of the repaired piles. And as you see, so you get 1,820 pounds per inch, and that you multiply that by the circumference of the jacket or circumference of the pile, and that is the total force that that jacket can develop in the vertical direction. Now, we've done, just to show you how this works, this is many years ago when we were taking a timber pile, and we have wrapped it in PileMedic jacket, and we have injected, in this case, this is our low viscosity resin that we have injected in here. And once we injected the resin, and by the way, these resins flow by gravity, you don't need to pump or pressurize them. Once the resin sets in, then we had cut that piece of wood in slices. And as you can see, and in fact, I can hold up here one of these for you. You see, this is how the resin finds its way into all these voids and cracks that normally are not visible from outside, but when you fill it with resin, you notice that the resin kind of magically finds all these cavities inside of the pile and fills it up. And so that's really the concept of how you would be using it to add to the strength of your repaired pile. I wanted to show you just a few pictures of some jobs before we jump on here and do the actual demonstration for you. These are some projects that in the last 4 years or so, we've been doing over 300 timber pile repairs for the Canadian rail system. And the fact that, these PileMedic is really has a low footprint, it's lightweight, you don't need a lot of heavy lifting equipment. It lends itself very well to these railroad bridges that are in remote sites and, oftentimes not next to a highway road. So in this case, as you see, they are wrapping the laminates tightly around the pile without any annular space. And usually the unevenness of the surface of the timber pile itself does create a small cavity to allow the introduction of this low viscosity resin, and then it finds its way through the cracks. Now, one of the things that sometimes we get asked about, what do you do with these bracing elements when you have already like an existing brace? So one of the ways that you could address that is take the brace out before you wrap the jacket, put a wooden peg in that hole if you want to use the same hole, put a wooden peg in there, wrap the jacket, inject the resin. Once all of it is done, then pull that wooden peg out and reinstall the bracing element through the same old bolt holes. So that's how you can achieve for that. And one other application, this is from a job in Australia. So let's say here, if you have a timber pile that you're splicing it, so we have a horizontal cut or like a seated cut that is in the horizontal direction, and then to bring back the flexural capacity of the pile at that region. In this case, we are adding some carbon laminates to the side of the pile, and then we wrap the PileMedic laminate around it, and that whole area gets resin injected. So now in this case, not only you get the flexural capacity of the jacket because you have glued it with that epoxy resin to the pile, but you also engage all of those carbon strips that are embedded in the annular space because they are now all epoxied together. So that gives you a lot of additional flexural capacity also. And this is a job in Imperial County, California that we just finished a couple of weeks ago. And Lex, who's going to show you this, he was on that job site. But I just wanted to show you again in this slide that first of all, you see this was a timber bridge. We repaired about 20 or so timber piles and 4 pile caps on this. And as you see in that lower left picture, not only the piles were badly deteriorated, but even the pile cap was severely split and decayed with, with aging. So the top 2 pictures on the right, I just put those in there so you can see that how small the footprint of the crew is. They basically had everything on the back of a pickup truck and set up a tent to kind of shield them from the heat of Yuma or southeastern California deserts. So the piles, and on the lower pictures, you see that the pile has been wrapped after these. In this case, we used some 1-inch spacers that put them around the pile and wrap the jacket around it to create that 1-inch annular space. And on the lower right photo, you see that they are pouring the mixed epoxy grout into the annular space on this project. And then when it came to the pile caps, one of the things you can use lag bolts to laterally bring back and pinch those separations and bring them back together. And then in this case, we wrapped the areas of the pile cap that was accessible. We wrapped it all the way around with a layer of resin saturated fabric. Then the other portions of it were also formed and wrapped completely encapsulated in a glass fabric. So it was completely contained. And then as you see, we can from some ports inject resin into it to solidify that pile cap. And then finally on the upper right corner, you see the finished project after it has been painted. So this is the kind of stuff that is becoming really popular for a lot of these bridges. And and this one, I guess this was the same for that same project. Just before I end my part of the talk, I'll be at a couple of these conferences. If you happen to be the 17th conference of FRP RCS or FRP in reinforced concrete structures, it would be on July 2nd to 7th in Girona, Spain. And then after that, I'm giving a couple of talks and a short course in Vancouver in the early August. There is the International Conference on Short and Long Span Bridges. So hopefully, if you happen to be in these areas, we'll get to see you and meet you and discuss any projects that you have. So with that, I'm going to kind of end. This is my part of the slide is going to end, and I have here with me, you have met Josh Ahumada before, and we have Lex come and join us here. This is Lex Pruitt. So Lex is the one who was on the job site before, and we've set up a timber pile, and they're going to show you how to actually, just so that you really have a feel for what this mixed resin, what does it look like, what is the consistency of it, and so on. Yeah. Yep.
Well, one thing actually I do want to remind everyone before we start is that here's a 1-inch spacer that we do have in this system right now, so you could see it. Obviously, it would be tied on right here. Another thing that I wanted to touch on before we go further, you obviously have maybe seen our wrap before, maybe not, but it comes on a roll and it's wrapped. This is 10-inch diameter. We're making a 12-inch shell. One of these rolls is about 1,575 square feet. So we're going to do I would say about 300 plus linear feet of repair by one roll of this. And that's doing constant overlap, so it's probably more. So imagine how much you're getting on these rolls, like how Mo described on the truck, low footprint. That's why we love this repair for our system. This is 10-inch, 14-inch. It's just a hodgepodge of things on the site. You can fix it. So I just wanted to remind everyone that so we can get into the mixing. So if you buy an epoxy grout kit from us, it comes in a kit like this. It's a 3-gallon kit. And we will send you 3 50-pound bags of aggregate. More than likely, you're not going to use the 3 bags. If you're going to keep it flowable, you're going to stick to 2 bags. What that gets you is a 1.1 cubic foot kit. The 3 bags get you 1.5. But for estimating purposes, we stick to the 1.1. So today, when we do the mix, we are going to stick to the 2-bag mix. But we do not need the full mix today. We need half the mix. So we're going to show you that we're going to portion that out. We're going to use 1 bag. And then we will pour it into the annular space with the PileMedic, we created a little funnel. So with that, we will get going. All right, let's grab those. Here, I'll grab some. So we got our 5-gallon bucket, and so we will use this bucket to portion it out because we need half a gallon. So here is one gallon. Here you go, Lex. You want to start getting that in there. And then what we have is the part B. You're always going to start with the A, and then you're going to add the B. Now, keep in mind, this is a very low viscosity epoxy because you're mixing aggregate into it. We want to get more yield out of the product. So now that we have done that.
Who's filling out the QC in the sheet?
No, I think that was
Not today.
You, Lex.
Yeah, they're talking about QC of the sheet. So usually on a job site, you would have to log in the lot number of the resin and to make sure that, you keep track of what went where for your record. Obviously, we are not worried about it today. But so Josh is measured like, is that half of a?
Yes.
So that's
half a gallon.
Half a gallon there, and we had 1 gallon of A, half a gallon of B. They're pouring it in there, and you see they're all very liquid, relatively low viscosity. So once you start that, now you start mixing it.
Now, if you hear me, it does say to mix 3 minutes, low RPM. So we're going to mix it. We're not going to take too much time, but we'll do a good mix. Make sure you get the pointers when you do mix. That is vital when you are mixing epoxies. Here's our 50-pound bag.
Normally we wear steel-toe boots at the job site.
Yes.
Just,
For
as
safety,
a disclaimer here.
By the way, another point, both of these epoxies, can be used above, obviously, on land as well as underwater. So they can be applied underwater without any need for cofferdams. They cure underwater.
And some people will pump it. So get to us on some suggestions on cleaning a pump. All right, so I'm going to start adding the mix. I want to check flowability before I put the rest in. What do you think, Lex? Yeah. I think we'll leave it at that. We pretty much got most of that bag in.
Can you scoop it so they see what it?
We're gonna pour it in here.
Yeah. And they will explain it to you, but anytime you don't want to let any time go by and let this sit there, because then the sand would settle at the bottom of the mix of the epoxy grout. So right now it's well mixed. They're gonna take it out and pour it into that bucket and start.
Now remember too, it's an epoxy. There are exothermic reactions. You do want to get it out. Even though we're spreading it with sand and it does reduce the exothermic reaction, you still will get it. It's an epoxy, so you want to reduce volume.
And and you see that it flows as you see how Lex is pouring it. This is just flowing in, and it would go all the way around the pile and find its way into all the voids and cracks. And then, before maybe we pick the next one again, you want to make sure you mix it to make
Yeah.
sure that,
Yeah, it's hard to see on camera, but you see it. The
yeah.
epoxy comes up a little bit.
Yeah, you know, the epoxy, obviously, the sand settles down to the bottom and the epoxy comes to the top. So you have to keep mixing it. But it goes really quickly, as you see here. This is in real time, and you just pour that annular space.
And it is flowing all the way around.
It is going
Epoxy
around,
likes to
yeah,
flow.
yeah. If by chance, you know, you have any concern about, you know, making sure that this goes around, you can always use a vibrator and externally hold it against the jacket, and that would, you know, rattle it and make sure it flows. But usually that's not even needed.
And in the field, we use a small mallet to see where you at in the pour.
So I would say we're about halfway up right now, or maybe a little more.
That's, yeah, it's good. Yes, keep going.
Normally, I only tell the people how to do it.
Yeah, they're already almost like up to here.
All right, be careful on the last one. And, Mo, tell them if we want to slope it, we might.
Yeah, you know, usually when you fill these up to the top, then you want to make sure that when you reach to the end, you would slope the finished surface with like a 2-to-1 slope to make sure that any water that is coming on the top, it would run off to the side of it. Yeah, they're almost getting to the.
Yep.
You want to.
Maybe just a tiny bit more, and we're there. Because then we would leave a tiny bit to fill that 220
Yeah,
on the top.
yeah. So the rest of it, you know, they can do it by, you know, either. And Josh, maybe you can show them what you use as like the funnel.
Yeah.
This is the piece.
PileMedic.
Yeah, we just use a piece of PileMedic and cut it in the field, you know, in that shape so that they use as a
And
funnel.
I did get a little on me, just soap and water. So I'm gonna.
Sorry.
Lex.
This was a part of the demo to indicate to you as a training that how if you get it on your skin, you can wash it up. All right.
All right. So yeah.
So this is all that needs to be done is just like then, you know, put a little bit of the last of it here and feather it, and that's it. It's just solid.
Also in the field, we do shrink wrap the pile before we pour.
To keep it
Just
clean,
because
yeah.
you can see on this side.
Yeah.
Or just in case too, like yeah. I mean, you do your best to seal everything, but it does help.
It helps.
It absolutely helps.
Yeah. So this is really about it. It's pretty straightforward and simple to do these repairs. And you know, I don't know if there is anybody that has any questions on the live audience we can answer, or if not, you know, we can contact us later if you have questions, and we look forward to working with you on your upcoming projects.